Hello, ladies and gentlemen. This is Mrs. G. Today we're going to talk about rational numbers. So far we've talked about fractions and decimals and negative numbers, and we've kind of talked about them all individually. Now we're going to put it together, and we're going to talk about adding and subtracting negative decimals, or adding and subtracting negative fractions, and also the multiplying and dividing as well. So we're going to talk about all four of our operations, but now adding in negative fractions and decimals. Just before we get started, let me talk to you a little bit about rational numbers and what that really means, okay? So basically, the inner set here are the whole numbers, okay? So we talk about the whole numbers as basically 1, 2, 3, 4, and so on up until, as long as you'd like to go. So 5 is a whole number, 8 over 2 is a whole number because it's really 4, square root of 9 is a whole number because it's 3. We add a few more numbers into that. We add many more numbers into that actually when we include the integers. Okay, so the integers are now the whole numbers, but we include the negatives. Okay, so now we're including things like -4 and -3. The rational numbers are one step even outside of that. We are including more numbers, and the rational numbers include the fractions and decimals, okay, things like this. Anything that can be written as a ratio or a fraction is a rational number, okay? So just to give you a little background, another way to think about it is the rational numbers are all the little in-between numbers that come in between your whole numbers. So if I'm looking at the top here of this number line, 0 to 4, the things on the top, those are the whole numbers. The rational numbers are anything that could fit in between two integers, okay? So with that, why don't we just get started? Most of my video today is just going to be working through example problems, okay? There's not a lot of new procedure here because we've done all of this already, but I just want to show you how things could get a little trickier, or just things to keep in mind as we talk about negatives. So why don't we start with decimals? Okay, we're going to start with decimals. And we're specifically going to talk about adding and subtracting. So you can feel free to write down as many of these examples as you'd like. I'd like you to write down at least one example per slide. If you want to just watch and take it in first, that's fine. So I know number 1 here says to subtract, but we still have to think about our methods of dealing with negative numbers. You can think about a number line, or you can think about our scoreboard, who wins and by how many. So if I'm looking at -1.25, subtract 2.30, really you want to ask ourselves, are those numbers on the same team or are they on different teams? Well, I have 1.25, definitely a negative, and I have 2.30, that's also a negative. So really these are on the same team. So I know it says subtract, but to find your answer, you're going to actually have to add those two values together, okay, because they have the same signs. When I add my scores over here for the negative team, I'm going to get 3.55, 3 and 55 hundredths. Clearly the negative team wins because the positive team doesn't have any points, and so my final answer here is negative 3.55. Okay, let's try one more. The second example here says add, and it is an addition problem because there is a plus sign in the middle, but we need to be a little smarter than that when we talk about how to actually go about doing the problem. No double signs to deal with, but basically we have 3 and 42 hundredths, that's on the negative team. 3 and 31 hundredths, that's on the positive team. So if I want to figure out who wins and by how many, let's just start with who wins. Who wins the game are clearly the negatives, but by how many, we're going to have to subtract. Okay, we're going to have to subtract. So 3.42. Remember all of your rules about adding and subtracting decimals, where we make sure to line up the decimal points. 2 minus 1 is 1. 4 minus 3 is 1. 3 minus 3 is 0. So really my final answer here is negative 11 hundredths. Okay, so those are my two example problems. Feel free to pause and copy one of those down, or both of them. It's up to you. But that's how we're going to deal with adding and subtracting decimals when they happen to be negative numbers. Why don't we move on? Now, before we get into fractions, I want you to understand a little bit about how we can express something like negative 1/2. I'm simply picking an example. I picked 1/2. This negative sign can exist just straight out in front, kind of in the middle of the numerator and denominator. Or you could think about taking that negative sign, and it would be okay to say that that's the same as -1/2. Because a negative divided by a positive is still a negative overall. Okay, that would also be the same as writing 1/-2. Okay, these are really all saying the same thing. Well, because 1 divided by -2, or a positive divided by a negative, is still a overall negative quantity. What you cannot write, okay, this is the important bit, what you cannot write is -1/2. Okay, this negative sign that's out in front here, it can't go to both of your numbers, both the numerator and the denominator. Okay, that's a no-go. The reason for that, if you think about a negative divided by another negative, well, that's going to equal a positive. Okay, so -1/2 is really the same as +1/2, and that's, not what we started out over here or over here. If you want to summarize this in a nice, pretty little chart, basically, we have it here. I can write -1/2. I can write 1/-2. I can even write it straight in front, -1/2. But I can't write that one there. Okay, so just to get started, just how to kind of express negative fractions. Feel free to, again, write that down if you'd like. Now, let's start to actually add and subtract. I'm going to start with my first set of example problems here that have the same denominator. Let's just keep it basic for the beginning. Remember, though, in general, when adding and subtracting fractions, we do need to make a common denominator. Okay, this number here and here that's on the bottom, it has to be the same. Okay, we have to have the same size slices of pizza. We have to have the same size fractions before we can add or subtract. So, keeping that in mind, the 5 just comes along because that's the same denominator. Sorry, it's a bit messy. And then on the top, we just do 2 minus 4. 2 minus 4. I'm going to write it out in some in-between steps just to really help us understand what's going on. 2 minus -4 is -2/5. Okay, the negative team wins by 2 points. Okay, so that's our first example there. Our next one, -2 minus 5, is actually what's happening on the top, over 9. Okay, the 9 part, the denominators are already the same, so that just comes along. And I write, okay, take this sign. This is where our last slide, what we just talked about previously is important. This negative sign, that's generally here in green, right above -2/9. Okay, it's not helping anyone if I put it on the bottom, because now I have 2/-9 minus 5/9, and now I've taken my denominators that used to be the same and now they're different, and that makes the problem more difficult. Okay, so I don't want to do that, but I don't want to just avoid the negative sign altogether. Okay, I have to do something with it. So really what you want to do is -2/9. Think about that as -2/9. Because then you still have your denominators that are the same. 9 gets to just come along. Okay, so I hope you can see why this is -2 minus 5. And then my final answer is going to be -7/9. Because these are on the same team. -2 minus 5 is -7. Okay, so if you're ready, we're going to move on to some with different denominators. The procedure is still basically the same. We just have to take this first step and make common denominators. So 9 and 7. Not a lot of things that 9 and 7 have in common. They're both odd numbers. 7 is a prime number. So really my common denominator here is going to be 63. Okay, so what I want to do is I want to change these into something out of 63 and something out of 63. Be careful that all your negative signs and your subtraction signs come along like they're supposed to. Okay, don't forget about them. So we have a negative in front, and we have a subtract here. To go from 9 to 63, I'm going to multiply by 7. So I have to do the exact same thing on the top. 5 times 7 is 35. Okay, I'll change colors. To go from 7 to 63, I multiply by 9. So on the top here, multiply by 9, and now I have 36. Okay, let me see. There we go. Move that over. So really what's happening, I have a lot of stuff going on here. Don't forget, I have a negative sign out in front, and I have a subtraction here. So that's going to be negative 35, subtract 36 over 63. 35 and 36 are both negative numbers. They're on the same team. So essentially, I'm going to add them up. Okay, 35 for the 35 for the negative team, 36 for the negative team. The negative team has 71 points, so it's going to be negative 71 over 63. I can't simplify that. I'm pretty sure 71 is a prime number. There's not really anything that's going to go into 71. So that is my final answer. Let's try one that has some mixed numbers. Okay. I think I'll just, there we go, give myself a bit more space. Yeah. So really what's happening in this example here is I have a subtraction problem, right? But I really want to ask myself again, who wins and by how many? So I have 1 2/3 for the positive team. I have 4 5/8 for the negative team. So these are on different teams, so I need to subtract. Okay, so I know this seems a bit odd, but in this problem, I actually need to take 4 5/8, subtract 1 2/3, but just keeping in mind my final answer is negative. Maybe you want to put that up there wherever you're going to write your answer so you don't forget. It's a negative answer because 4 5/8 is larger. That negative team wins the game. Now let's do the working out down here. 4 5/8, subtract 1 2/3. What is my common denominator here? I'm going to go with 24. Okay, so 5/8 here I'm going to have to multiply by 3. So my new numerator is 15. Here I'm going to have to multiply by 8. So my new numerator is going to be 16. I'm subtracting, and I can't do that. I can't subtract 16 from 15. So maybe I want to make things in improper fraction. This is a tough problem, guys. So let's see, 24 times 4. And at this stage, if you were doing this problem, it's fine to grab a calculator. This situation, just punch it in. So 24 times 4 is 96 plus 15. We have 101 over 24. Subtract 24 times 1 equals plus 16 is 40 over 24. So what I just did is I made this into an improper fraction here, and I made this into an improper fraction here. And my final answer is 71 over 24. And again, it's okay if you popped those numbers in the calculator. My final answer is negative 71 over 24. And that's probably as tough as it's going to get, guys. So don't worry if, I want to show you the final end of the trickiest problem that you could possibly see. But don't think that this is the norm. Okay, don't think that's the normal problem. Actually, my example here in number 3 is really very simple. 6/7 plus negative 3/7. I wanted one with a double sign to remind us, a plus negative. Let's just change that into one big subtraction. And now this really isn't a negative. There's really no negatives involved here. I'm just doing 6 minus 3 to get 3 over 7. Okay? So lots of different levels of things going on here. I just want you to be able to watch and see what happens when we deal with fractions and negative numbers. So just be careful. With adding and subtracting, we're still kind of thinking, who wins and by how many. And try not to forget your negative signs, okay? Try not to forget those at the end. Let's go on. Let's talk really briefly, and this is the last slide, so stick with me. Multiplying and dividing. Okay, we have our love and hate method. All we have to do is basically multiply and divide like normal, just don't forget your negative signs. So if this is a fraction problem with dividing, we're going to do KFC, because that's what we've always done before. So I have 3 over 4 times 6 over 1, and all I have to do is do multiplying across. 3 times 6 is 18. 4 times 1 is 1, but don't forget your negative symbols. And then also, don't forget to simplify. Both of those are even numbers, so I'm going to have negative 9 over 2. Okay, it's not really so difficult. You just can't forget your negative signs. Okay, for number 2, maybe some of us remember cross-canceling. I haven't taught you guys that yet, but you can simplify here and also simplify here if you'd like. Okay, so 2 and 8, I can divide both of those by 2. This becomes a 1 and a 4. Here, I can divide both of those by 3. It becomes a 1 and a 1. So a negative times a negative is equal to a positive. It's okay if you write a little plus sign to remind yourself. It's not necessary if you would rather not. So I have 1 times 1 is 1. 1 times 4 is 4. If you're not sure how the cross-canceling stuff goes, we'll talk about that later on in class. But I think some of us are ready for it. And then last but not least, let's do a dividing problem. To be honest, I'm going to take that negative sign and just disregard it. Somewhere, wherever I plan on putting my answer, I'll put a negative sign. Because it's a positive divided by a negative makes a negative. Okay, if you love to hate, you're a hater. Okay, I like to do that right at the beginning so that I don't forget. Negative something. So now, 0.4 being divided into 2.92. I have to slide my decimal point over one spot. It's good we're doing this because it's a really good review of decimals and fractions. So 29.2. If you do shorthand division, that's fine. Let's see, 4 into 28. I'm going to erase this for now. 4 into 28 is 7. I'm sorry, 4 into 29 is 7. But when I multiply them, I get 28. 1, 2. 4 into 12 is 3. 3 times 12 is 0. Okay, so I have a 0, so I know I'm done. My decimal point goes straight up, and I have 7.3. But it's a really good idea somewhere else to write your answer and say, hey, this is equal to negative 7.3. So don't forget your negative sign, 7.3. Okay, that's it, ladies and gentlemen. Go ahead, take some notes, write some example problems in, but we will talk about this more when you come back to class. Have a good afternoon, have a good evening, and I'll see you later. This is Mrs. G signing off.